Welcome back to Energy Material Research and Fund. So over to Professor Tapas Ghatak. We will know more about Chem. Over to Professor Tapas Ghatak.
Okay, thank you, Professor Nayak. Okay, so let's start from where you paused in our earlier video. So let's open ChemDraw again. So I just select, oh, just a minute. I have to share my screen, sorry. Yeah. Is it visible, Professor? Is it visible, Professor?
Yes, yes.
Yeah. Okay, so this is my screen. As I told you, I actually keep my ChemDraw in taskbar. Just select it, and now this is open. So what I want, actually, I told you, once it open, I feel that this template is a little bit short for me. It's not very, big enough. So I want a little bit big template. So go here, file, and then one option is there that is called page setup. You go here, simply select it here. Now, when you open it, you can select, you can see a lot of options are there, right? First option is size. So it is automatically selected as a letter. Okay, if you drop it down, then there are a lot of options are there. B2, V4, just like your normal page size. Your then A4. This is nothing but A4 sheet size. Okay, so these are the different options are there. Okay, and I want my page little bit big, will be little bit big enough. So I choose legal. Okay, so legal actually is big enough, right? So you select legal, and then I select landscape. You select it here, then you put OK. Once you put it, then you can see here it is converted all the template to the window, right? It is covering all the windows. Okay, so now the space is big. You can draw whatever you want, whatever you want to draw, you can draw it. Even if your structure is very big, you can easily accommodate in the page, right? So let's start it from where actually is pause in last video. So here, view. So what are the options are there in view, right? So I told you that we have styles option, then object toolbar I told you, the structure toolbar I told you. Then we have a very beautiful options is there that is called periodic table. For example, I told you you can write whatever you want, any atom, any molecule, right? You can write it, or even for atom, you can actually select it from periodic table, right? So you can see here we have option show periodic table window. You select it, and then the periodic table is open to you, right? And then from here, whatever atom you want, you can select it, and you can draw whatever you want. For example, I want a copper bond, right? So what you want to draw copper bond. So you select here. I can see a copper molecule, copper atom is here. You select here, then just click on here. You can see here already automatically copper came, right? And I want that copper should be a little bit big in size. So again, you go to lasso tool, and then you will select a little bit larger font size. So now it is 16. I want another copper. So again, I make a bond between copper and copper. So I select single bond, and then you go here. Okay, I want another copper should be there. So select copper, and yeah, I want that copper should be placed exactly on the bond. So once you come near to the bond, you have to come such a way that one bond open that should be in blue color. Okay, so come here, and then you can see here, once you come close enough to the bond become blue. Okay, then you click it. You can see here I put copper. So whatever atom you want, you can choose it from periodic table. Either you can write it, or you can choose it from the periodic table. Okay, so this is the role of periodic table. Now what the other options are there, you can see here we have another important option that is called character map window. Okay, so if you open it, you can see here is character map window is open now. So what is actually it contain? It contain all the alphabets. You can see here 0, 1, 2, 3, all the digits are available here. Okay, you can have, alpha, beta, gamma, all these things. If you want to select it, you can do that. For example, I want to write alpha. So what you do then? You just select A, text, that is A, you write it here, and then I want to write alpha. So here you can see here, we have alpha. So go here and then select it. It's automatically came as alpha. So from character window, you can choose lot of things. You can see here others option. You can select right. Okay, that is root. Then caps A, caps B, X. Then thermal delta. Okay, then you can see here M, N. Okay, you can have different kind of box, different arrows, right? Up arrow, down arrow, okay, right arrow, left arrow, all these options are there in character window. You can choose whatever you want. Then what are the next options is available here? Template. Okay, so it's a very nice options that we have in view. So here, once you select or you click on template, you actually open different options. You can see here what are the options are available here. You have advanced bio draw. Okay, you can draw a little bit complex biomolecule here. You can draw amino acids. If you select it, you can see here automatically the system will give you a lot of options. All the amino acid options will give you. Okay, you can select whatever you want. You don't need to draw it actually. You can actually select it and you can place it in your ChemDraw file. For example, I want this one. Okay, right. So select it and then just click it. You can see here. Yes. I just get it from amino acid template. Then what are other templates are available? You can see here amino acid. Then anatomy, animals, even you can see here. If you select it, you can see here all the animals are there. Okay, you can pick whatever you want. Animals, bird, okay, reptiles, all options are there. Then aromatics. Okay, for example, we have a lot of aromatic ring. You can see if you select it, these are the aromatic options are there. Okay, you can choose whatever you want. You don't need to draw it. You just select it. For example, I want biphenyl. Just select it, biphenyl. Right. I want naphthalene. Select naphthalene. Click it. I can get whatever I want. I want, Buckminster fluorine. You can see here. Yeah.
Yes.
You see it. Okay. I want porphyrin. You can see it. It's a very complex molecule, porphyrin, right? So I don't need to draw it. You just select it and click it. I have the porphyrin molecule.
So,
okay.
Professor, this fullerene structure, suppose I want to see like the visualization of CH4. Similarly, if I want to see this fullerene structure also there, is it possible to see the 3D view of this?
Yeah, of course. Let me see it. Let me see it. How fluorine molecule actually look like, right? So you can see here in my template, I have different molecules. I have biphenyl, I have phenyl, I have porphyrin, I have copper, then I have one amino acids. I want Buckminster fluorine. I want to see only Buckminster fluorine in 3D view. So what do you do then? Okay, selectively you have to select fluorine. So you just click on lasso tool and then you select fluorine. Okay, buckyball, and then you go to view options and so Chem 3D. Click it here. You can see here.
Oh, why it is not coming like a bulky ball? Like here you can see it.
Because you can see here, maybe all the atoms in the molecule, vacuole molecule, whatever actually system is drawing.
Yes,
is
maybe the
not
drawing is
sp2
this way.
hybridized.
Yes,
it's
yes.
not sp2 hybridized.
Yes.
Okay,
So
all the bonds are actually not properly given.
Yes, yes. But if we will draw, then definitely maybe we can able to see this.
Yes, if you place the double bond in a proper place, if you make all the carbon in sp2 hybridized in buckyball, then it will be look like a beautiful real buckyball structure.
Yes, yes.
Okay, right. Then what are the other options in there in template? You can see animals, aromatics. Then bicyclics. If you select it, you can see here a lot of bicycles. I mean, 2 cycles are joined. Okay, they actually 2 cycles actually shared a bond. You can see here we have a 6-member ring, 4-member ring. We have a 6-member ring, 5-member ring together. Okay, you just select it whatever you want. It's called bicyclic system, right? So you can select any one that you actually want to draw. Then these are the different options are there. There's CP ring, okay. Then a DNA template, then hexose, for example, glucose molecule, okay. You can select whatever you want. There are a lot of glucose molecules are there, okay. Even you can see the options is already there, okay. So you can select whatever you want in your paper. You can select it as it is from the system, okay. Then hexose are there, hexose. Then nanotubes. Even you can draw the nanotubes. You can see here. These are the different nanotubes. Okay. Just let's try to see the nanotubes in 3D. Let's see how it look like. Okay. So this is nanotube. I select first one. So this is
armchair
molecule. Okay. So let's see how it look like in real 3 dimensions. Okay. So you select it. Then let's see how it look like. Go to view and 3D. You see
yes,
here.
this is okay. This is
Nicely it
completely
is showing the
yes,
nanotubes.
very nicely presented.
Nicely it is showing the nanotubes.
Yes.
Okay. So this is very beautiful options. Okay. So you don't need to draw.
If we want to take this one also, and we can also take it like here
you
also
can import
copy
it.
and paste same way, or
yes, 3-dimensional picture. I will show you in the next video how to import the 3-dimensional pictures in your paper directly. That you can do. Okay. So these are the templates available. Then metallocene, right? For example, we have very well-known, a very famous metallocene is ferrocenes. So here you can see the different metallocenes options are there. You can choose whatever you want. For example, I want ferrocene. Okay, so select this one. Okay, so you know that ferrocene, the metal is actually iron. So it is in general it is written as M. So you want to replace it with iron. So what you do then? You can write as it is Fe, or you want to write from the system itself. So go here and then insert periodic table. Okay, and then you select iron. Okay, so you can select. So it's automatically came. So in this way, you can also write or draw different sandwich molecule. And then metallocenes, and then microorganism. Let's see what are the options are there. You can see here. These are different microorganism. Okay, we have also coronavirus. You can see here.
yes,
you can see here. It looks like a coronavirus. I don't know. Maybe, yeah. It looks like a coronavirus. Okay. You can see here. Professor, is it coronavirus?
yes.
It looks like, right?
It looks like coronavirus. We can 3D also. I think it is in 3D. It looks like
how it looks
3D.
like. Yeah, let's look like how it looked like in 3D. No, it's not able to, because there's no real atoms are there. There's no atoms.
Yeah,
so 3D can actually convert atom to the 3 dimension. So there is no atom.
yes.
Okay, that's why it's not able to convert it. I hope so. Okay, so go to view. Let's see what are the other interesting features are there in view.
Template.
So we have nanotubes, we have organelles, pH rings, polyhedra. Okay, you can see here what are the polyhedra I told you. You can have different polyhedra, tetrahedral, octahedral, okay, the icosahedrals, all the polyhedra. You don't need to draw it. System is automatically giving you the options, different polyhedra options, right? And then pH ring, polyhedra, then polypeptides. Okay, if you are a bio-inorganic chemist or bioorganic chemist, you need to draw this different polypeptides. You don't need to draw it. You can select it from the system itself. So these are the different options are there in view, right? Now come to the next one, that is called objects. Okay, so there are also few interesting features are there in object. For example, first one is object setting. What do you actually mean that? Object setting, for example, I draw a simple methane molecule. Let me remove all the things. If you want to remove all the things, just select Ctrl A, it will be selected, then press delete. Automatically delete all the things, existing things. Now I want a methane molecule, simple methane molecule. So what you do, carbon, and then you put like this for hydrogen. Now you can see here, I actually drawn it incorrect way. You can see all the bonds are actually different size. Okay, if you want to do it manually, of course you have some mistakes. Okay, you cannot put a measured bond distance if you draw it manually. So for this, system actually give you one options. You don't need to draw it manually. So what you do then, go to objects and select fixed length. Okay, so just select fixed length. If you select fixed length, then what you do, I want to draw methane molecule. Then if you select fixed length, now it is automatically, you can see it's automatically select fixed length, right? It is already clicked. Now I want a bond. So what you do, I make a bond here. If you want to make a bond here, as the system automatically fixes fixed length, you cannot increase the bond length. It automatically takes whatever actually system actually prefer. Okay, so in that case, all the bonds should be in the same length. Okay, you don't need to worry about that. You can see here, even if you want to increase it, you cannot increase it. So this is the role of fixed length. Okay, you cannot increase the bond length, but if you want, the bond should be different length, then again you go to objects and remove the fixed length options, and then if you want to draw, you can draw whatever you want. You can see here, I can draw a very big line. Okay, so this is the role of fixed length.
Fixed length, if suppose I want little bigger size but fix all, but little big means length little more I want. So that also you can do.
You want a big length or big thickness? A little bit more thickness.
More, big length.
Yeah, so in that case you have to unselect the fixed length option. You see, you see here, there is no selected. It is unselected, right? Fixed length. Now you can draw whatever you want. Your length should be whatever you want. You can draw. Just you select it, and then you can see here, I can draw whatever you want.
Yes.
The length. Okay, now what are other options there? Fixed length, then fixed angle also. Okay, if you want exactly your methane molecule should be tetrahedral, then angle should be 109 degree. Okay, so you can actually fix the angle like this. Okay, so stereochemistry, you can see the stereochemistry, align and distribute, all these things are there in object setting. Okay, for example, again, I want ammonia molecule, right? Draw here ammonia molecule. Okay, so I put N and then you connect it on the hydrogens. Okay, so this is NH3, but still it is not completed. I put NH3, but the ammonia actually is not ammonia, it's NH3. But if you put a lone pair on hydrogen, that is a complete ammonia molecule. So from where you import a lone pair of electrons. So you can see here, we have options here. That is called chemical symbols. Okay, you just select it here. Once you select chemical symbols, okay, and what are the options are there? You can see here, we have a positive charge. If you want to create a positive charge, you can select it. Positive charge in circle, positive charge, a discrete positive charge, then a cationic radicals. You can select a radical with positive charge. Then you can see here a lone pair. Okay, if you select it, I want to put on nitrogen, so come close to nitrogen and select it. You can see here I put nitrogen with lone pair. Okay, then your lone pair is moving. You can select these options. Then you want to put a negative charge with circle. You can see here this one. I want that ammonium ion. Okay, so what you do then? I need ammonium ion, so NH4. I put NH4. You have to remove the lone pair. I remove lone pair, and then I put NH4. But you know that in ammonium ion, the nitrogen is actually positively charged. So what you do then? You select positive charge, right? And then you come close to nitrogen. You can see here when you select nitrogen or put your cursor on nitrogen, it's become blue. Then you click it. You can see here. So you can actually relocate the positive charge. Select it from here, and then you can place it in the suitable positions. So now you can see here ammonium actually is a NH4 plus ion. So in this way you can use the positive charge, negative charge, then radical cation, radical anion, okay, carbon ion, carbocation, all these options are there. Then we have a dash bond, we have a wave bonds. Okay, here we have different other heterocycle. We have cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane. Even you can draw the different chair conformer of cyclohexane. For example, this one. You can see here, you don't need to draw the chair conformer by your own. You can select it from the system. You can see here, this is the chair conformer of the cyclohexanes. Okay, so these are the options are there in main toolbar. It is a very style toolbar. It is a very useful tool. Okay, then object is finished. Then I want to show you another interesting feature that is called, I told you that I draw an ammonia molecule. Now selectively, if I want that one of the bonds should be a little bit thick in size, then what you do? Selectively, you don't want all the bonds should be thick in size, only one bond should be a little bit different from other. Then what you do? You select this bond, any one bond that you want to do it, you can select that bond, right? And then you right click on there. So I do the right click here. Once you do a right click, then you can see here a lot of options are there. You can change this bond single to double. Single bond, it can be plain, it can be dash, it can be hashed. Okay, for example, if you want to make a dash bond, just select dash bond. You can see here it's converted to dash bond. Okay, so I want it should be single properly, so it is plain single bond. Okay, you right click on there and let's see what are the other options are there. Single bond, double bond. You can convert single bond to double bond. For example, you select it plain. You can see here I convert nitrogen had a double bond. Okay, we are drawing. So I want should be single plain bond. And then what are other options are there? Let's see. Double bond, you can make a triple bond, quadruple bond. Okay, then bond position you can change it, bond properties you can change it, alter it, and then one option is there that is called object setting. Okay, you just go to object setting. Now once you go to object setting, you can actually edit the bond property, right? For example, a lot of options are there. You can change the line width, you can change the bold width, margin width, and hash spacing, right? So automatically when you draw a bond, system will tell you, or system actually select the bond which should be 0.0 to 1 centimeter, but I want a little bit thick, so you can change it whatever you want. For example, I want should be 5.2. Okay, so I select 5.2, then do it, select it, write it, and then put okay. You can see here only one bond actually we can selectively make it little bit thick or thin, whatever you want. Okay, not only that, Not only that, for example, you want to do it in an arrow. You do it, you draw an arrow, and then I want that arrow should be little bit thick in size. Okay, so select it and then right click on that and go to again object setting. Whatever the changes you want to go it, you want to do it, you have to go to the object setting options. So go to object setting. Once you select it, then this option will open. Line width, then bold width, all these things. I told you system automatically give you the options to 0.0 to 1 centimeter. Okay, and that you can do it or you can edit it. For example, I want 5.1. Okay, do it. You can see here now it's become a little bit thick.
Yes.
In this way, you can edit the bond, you can edit the arrow, or you can edit your structures, whatever you want. Okay, for example, selectively you want any one of the bond little bit, you know, it should be white bond. Then you select here this one. Then just right click on there. You select it and then right click. I want the bond should be changed to this one. Select it and then place it on that bond. You automatically the bond will change. Okay, this way beautifully we can draw your molecule whatever you want. Right, and another interesting feature that I'm going to tell you. That I'm going to tell you. For example, let me see it. Let's write benzene. I write benzene. Okay, and I want the formula benzene. Okay, if you don't know the formula of a molecule, you just write it. So in a system, it has some well-known molecules with the molecular formula. It should be well-known. If you just write it randomly, it will not able to give you. Okay, if the molecule is very common or normal, then system will give you the exact molecular formula. For example, benzene. Okay, I want the formula of benzene. So what you do, you write benzene, then you click it, you select it, then you go to structures. Then you can see here one option is there, name to structure. You select it.
I think benzene spelling, that's why it's not taking.
Okay, yeah, basically B-E-N Z-E-N. I think it's B-N-Z-E-N is correct.
Yes.
Let's see. You can see here.
Yes.
System is actually giving benzene structures. So if you don't know the structures, you can just write the molecule name and then you can convert it to structures. But you have to be sure that the formula, the spelling is correct.
I think we can more discuss about this from these two onwards. We can again more discuss about this Chem draw again. So thank you very much, Professor. So really, it is a exciting and interesting tool for drawing the structures, and we can also present very nicely in paper presentation. So at the I think after a few lectures, he will also, Professor Tapas Ghatak, will also explain us from how we can able to draw the structure which was presented in paper, how we can able to draw it using Chem software. Thank you very much for your time.
Thank you, Professor, for giving me time. Yeah.